When you picture a frog's life, you immediately think eggs, then those little wiggly tadpoles, right? Legs
Yeah.
pop out, tail shrinks.
Yeah, the classic metamorphosis. It's like biology 101.
Exactly. Feels like a fundamental rule. But sometimes nature just completely flips the script.
It certainly does.
And that's what we're diving into today, this major evolutionary surprise. We're talking about 3 newly discovered toad species in Tanzania that, get this, completely skip the tadpole stage.
That's right. They give birth to tiny, fully formed toadlets, little miniature versions of the adults.
Wow. So straight from mom to miniature toad. Which species are these?
We're looking at 3 new members of the Nectophrynoides genus. They're tree toads. N. luhomarensis, N. hihe, and N. saliensis, found in Tanzania's eastern Arc Mountains.
Okay. And this live birth thing, how common is that in frogs and toads?
Oh, it's incredibly rare. Live bearing or viviparity, you see it in less than 1%, seriously.
Yeah.
Out of almost 8,000 known frog species worldwide.
Less than 1%. That's astounding. So they skip the whole tadpole bit in the water. What's the term for that again?
It's called direct development. Basically, the young hatch are born looking like tiny adults. They bypass that whole aquatic larval phase that most amphibians rely on.
Right, direct development. So why did these toads evolve this way? I mean, it seems like a handy trick if water is scarce. Why isn't it more widespread?
Well, it's a massive biological investment for the mother. Think about it carrying developing young internally instead of just laying eggs somewhere.
Okay, yeah, more costly.
Definitely. And for these specific tree toads, it seems to be driven by their environment. They live in low vegetation, often quite far from reliable ponds or streams in those mountains.
Ah, so laying eggs in water just wasn't really an option, or maybe too risky.
Exactly, too far. Maybe the water sources weren't permanent enough. So evolution favored this strategy, internal fertilization, live birth. It sort of became the safest bet to deal with that constraint. A safe harbor, evolutionarily speaking.
A safe harbor. Born out of isolation in these mountains. Okay, so how did scientists figure out these were actually new species, especially in a genus already known for, being a bit weird reproductively?
That's where it gets really cool. They used a technique called museomics.
Museomics. Sounds like something out of a museum, which I guess fits.
Precisely. It's
Okay.
genomic archaeology. They actually extracted DNA genomic data from the original museum specimens.
Original specimens. How old are we talking?
Collected back in 1905, so over 120 years old, and often preserved in formalin, which really degrades DNA.
Wow. Pulling usable DNA from something that old and chemically treated. That's impressive.
It really is. And that fragmented data was enough to confirm these were genetically distinct lineages, likely separated for maybe millions of years in those forests. Deep, distinct lineages.
That ability to find crucial insights in tiny, old, complex data points. It really highlights the power of advanced analysis, doesn't it?
Absolutely.
And, speaking of leveraging complex systems and data to find hidden value, that really connects with the work of our sponsor, Embersilk. If you need help with AI training, automation integration, or even software development, or maybe you're trying to figure out where AI agents could make the biggest impact for your business, or even just for you personally, check out embersilk.com for those kinds of advanced AI needs.
It's true. These modern techniques like museomics are vital because these toads, these highly specialized species, they're really vulnerable.
Vulnerable how?
Because they're so specialized.
Yeah, partly. The Eastern Arc Mountains are what we call a biodiversity hotspot. Amazing variety of life, much of it found nowhere else. But they're facing serious threats.
Like deforestation.
Exactly. Logging, mining, habitat fragmentation, and climate change on top of it all. It's hitting these isolated populations hard.
So the very strategy that let them thrive without ponds' internal development, likely smaller populations, needing that specific forest type that now makes them fragile. Precisely. That huge parental investment, that specialization, it works great in a stable environment. But when the habitat shrinks or changes quickly because of human activity...
They can't adapt fast enough.
Right. Their life history is too constrained.
Yeah.
And this isn't just a theory. We've seen it happen. A close relative, Nectophrynoides aspergillus, it's already extinct in the wild because of these pressures.
Oh, wow. That's sobering.
It is. So you have this incredible evolutionary success story, right? Toads becoming completely independent of standing water. But the deep irony is that this safe harbor, this highly specialized approach, it actually makes them incredibly sensitive, perhaps the most sensitive, to the rapid global changes we're seeing now. Changes happening way faster than their evolution can track.
The safest evolutionary path becomes the most dangerous under rapid change. That's definitely something to think about. What an amazing story, though, even with the concerns.
Truly remarkable creatures.
Well, if you enjoyed this deep dive into the world of tadpole-free toads, please subscribe to the show. And hey, maybe leave us a 5-star review if you feel like it. It genuinely helps other curious minds find us. Thanks so much for tuning in.